Hey, welcome to The Explainer. Today we are diving deep into a phrase that you and I, well, we probably use it all the time. It's a phrase that feels like the absolute bedrock of our scientific world. But what if I told you that the very scientists who depend on it the most can't actually tell you what it means? Objective fact. I mean, it seems pretty simple, right? It's just something that's true. Period. It doesn't matter who you are, what you believe, it's just a fact. We build our entire understanding of reality, especially science, on this solid-as-a-rock idea. But here's the twist. What if that bedrock concept is actually a total mystery?
And here is where it gets really wild. Now look, this isn't some critique coming from outside the world of science. This is a confession from inside the house. The very people we count on for precision and clarity are admitting, hey, we're using this super important term, but we've never actually defined it. And that, right there, is the mystery we're going to solve today.
Now, this isn't just some small academic quibble. Oh no. The source material we're looking at calls this a full-blown linguistic crisis. Think about that. A problem with our words so fundamental that it could actually threaten the integrity of science itself, blurring that crucial line between what we've actually observed and what we just want to be true.
This brings us to the real heart of the matter, something called a definitional void. You see, when scientists throw around the phrase objective fact, what they're often doing is signaling a level of certainty that, frankly, hasn't been earned yet. It's kind of like writing a check for $1 million when you don't have the money in the bank. The words sound impressive and solid, but the definition behind them, it's hollow.
And yeah, this is the core of it. Right now, in the hard sciences, there is no formal, standardized, everybody agrees on it definition for objective fact. For fields that are built on rigor and absolute precision, that's a pretty massive weakness at the foundation. How can you possibly build a towering skyscraper of knowledge on a foundation you can't even define?
So you might be wondering, okay, if the definition is so shaky, how has science gotten anywhere? Well, that brings us to a really interesting paradox. You see, science isn't some static library of books filled with permanent truths. It's a living, breathing, evolving process. And what we call a fact today is often just a stepping stone, a really useful model that helps us get to the next, even deeper understanding.
I mean, just look at gravity. Was Newton's idea of gravity as a force an objective fact? In the 1700s, you bet it was. But then along came Einstein, who showed us it was actually a brilliant approximation. His fact was that gravity is the curvature of space-time. And now, quantum mechanics is whispering that there might be a whole other layer involving something called the graviton. You see, each fact was just a model, indispensable for its time, but never the final word. And this is where the real danger creeps in. When we slap the label objective fact onto a theory, we're kind of, without meaning to, signaling that the conversation is over. We're putting up a big do not disturb sign on an area of science that might desperately need more questions, more poking and prodding. It can literally stop the next big breakthrough before it even begins. So let's break down these risks, because they're pretty serious. First, you've got ontological inflation. That's a fancy term for when we start thinking our map is the actual territory, mistaking our current model for reality itself. Then there's epistemic closure, which just means we stop asking questions because we think we've found the fact. After that, you get semantic drift. This is when objective stops meaning true and starts meaning, well, this is what all the important people agree on right now. And finally, categorical conflation. That's when we get confused and think the clean, perfect world of math is the same as the messy, unpredictable physical world we actually live in. Okay, so if this is such a bad habit, why do some of the most brilliant people on the planet do it? Well, the answer isn't really about logic or data, it's about something much more human. It's about sociology. There are these intense pressures in the academic world that push researchers towards using this language of absolute certainty.
Just think about it for a second. If you need to get funding for your research, or get tenure at a university, or get your paper published, you have to project total confidence, right? You have to sound like an authority. And so the phrase objective facts becomes this incredibly useful tool, a kind of rhetorical shield to protect your work and signal to everyone, hey, I'm on the right track here, even if the research is still very much a work in progress.
And right here, the real motive just snaps into focus. The phrase isn't really a scientific description anymore. It's become a social signal. It's less about accurately describing the universe and more about navigating a career, about showing you belong. It's a tool for validation, not just for verification.
But here's the good news. our source material doesn't just point out the problem, it actually proposes a solution, a whole new framework for how we talk in science, one that demands way more precision, more honesty, and a lot more rigor. It's about moving away from all that rhetoric and getting back to just clearly describing reality.
So the proposed solution is this really strict three-step test. Before you can even think about calling something an objective fact, it has to pass these tests. 1. The claim has to fit neatly into our current, well-described map of reality. 2. It has to stay true no matter how you test it or who's looking at it. And 3, and this is so important, you have to be able to explain how someone in the future could prove it wrong. It's a really high bar, and you know what? That's the whole point.
So what does this shift actually look like? Well, instead of just vaguely claiming you're on the right track, you have to demand hard proof that holds up across different scientific models. Instead of leaving words undefined, you define them with surgical precision, and you replace that rhetorical shield with a much more honest description, something like a provisionally verified observation. See the difference? It changes the whole game from defensive certainty to open-minded exploration.
All right, let's zoom out for the big finish. What's the real takeaway here? I mean, this isn't just some internal debate for physicists to argue about. It's actually a huge lesson in how we approach knowledge itself, and it has a really powerful message for every single one of us.
The ultimate goal here is to get back to something called methodological humility. All that means is embracing the idea that everything we know right now, it's just one chapter in a much, much larger book that's still being written. It's about being honest about the limits of what we know and remembering that the search for knowledge is a journey, not a final destination.
And that really is the bottom line. The second we start caring more about sounding certain than we do about being truthful, we've lost our way. The whole point of science, and really any search for knowledge, should be the honest, sometimes messy pursuit of truth, not a performance where we pretend we've already found it all. And this matters because public trust in science hangs on that very honesty.
And that brings us to our final thought, a question for you to chew on. This entire explainer has been about the incredible power hidden inside just 2 little words. So my question is, where else does this happen? Think about politics, our relationships, our jobs. How often does the language we choose, maybe without even realizing it, end up building the very reality we think is true?